So we're just going to drop in a server. We're also going to go over here to grab actually while we're here, we could grab a laptop or desktop. It really doesn't matter. And then we could go back. We're going to grab a 2960 switch or whatever switch you want. It's going to be unmanaged, so we don't need to worry about configuring it or anything. We're going to grab an SBC board. Now, what I need you to do is click the SBC board, go to physical, grab, if I zoom in here, you're going to see there's a little spot here, right, for a module. We're going to grab the 1CFE module, which gives us an Ethernet card. Now we could go ahead and close this out. We should cable our devices right now. So I'm just going to run some Ethernet cables to the switch. Again, it does not matter which port on the switch you plug these into because we are not doing any configurations on the switch. It's going to be an unmanaged switch. And then again, just plug it right into your SBC board. Now, I'm going to just visually name these again as a visual reference later on. It helps us out a little bit. He's going to be 1.3.3.3. Yes, I know this is not a standardized IP addressing scheme, but it's a lab and it just makes life easy. And for server 2, he's going to just be 1.1.1.1. Beautiful. Now we should go a step further and go into desktop, into our NICs on here and IP addresses. The laptop is 1.2.2.2. Tab that out for the gateway mask, or I'm sorry, the subnet mask. Close him out. Let's go to the server. Same thing, desktop, IP configuration, 1.1.1.1. Tab him out for your mask. And then our SBC board here, we could click, go to desktop, and I'm sorry, we got to go to config on the control board. We're going to go down to fast Ethernet adapter here. IP address will be 1.3.3.3. Tab him out, and all is good. Now, first things first, let's start pulling in our IoT devices, right? So let's go down to our board. We need to hit actuators. We're going to bring in the RGB LED, and you can notice that, I can't speak today. Notice that at the bottom in the middle center of your screen says RGB LED. Just drag that baby up. You can put these wherever you want, but try to follow the pin layouts I use. That way it makes sense when we're actually doing these. So the other thing we need to do is click the sensors, and we're going to grab this guy right here. It says motion sensor. I'll just put that right about there. We could go back to our end devices. We're going to click on the little home icon, and we're going to grab a door. And again, it does not matter with placement. In fact, sometimes it makes it a little neater on the screen if you separate them a little bit better. So I'm just going to name these devices, okay? It doesn't really have any impact on what we're doing in this tutorial, but it just helps visually represent them so it's easier on us later on. I'm going to name this door indicator, and obviously this is just a light. I'm just going to say motion lights. And you know, I'm mostly doing this with you, so when you start practicing on your own, you could, you know, kind of just have an understanding of what I was going for with this. So this is going to be motion door, whatever, motion door, and obviously this is our motion sensor. We really don't need to put anything there, but that's our motion sensor. So now we need to connect these devices to our board. Now here's where you do want to pay attention to the pinouts, just so you're following along with my pinouts and it starts making more sense. We're going to grab the IoT custom cable and go from D0 to D0 on the motion sensor. And then again, we're going to go to D2 to, let's do A0. And then we're also going to go from D3. I completely skipped D1. That's okay. We'll go to D3 to A1. Go back here, we're going to connect from D1 to the door to D0, and then we're also going to go ahead and do D4 from the controller to D0 on the light. Alright guys, so right now at its most basic, everything is going to be working for us. However, I mean, everything's connected and will work once we start programming it. So let's just explore this a little bit. When I click on this device, the controller board, all I'm going to do is go to programming, click new, and you're going to notice we can name this whatever we want. We could say Blockly Lab, okay? And then the template, we have JavaScript, we do have Python, and we have Visual. Now Visual is just because it's a visual programming language, if you will. I mean, in this, it's working off of JavaScript, but you get the idea. But it is known as blocky. That's the terminology flowing out there. There's a paradigm of it going on. And again, Fred Abley, getmecoding.com. Check them out. Subscribe. Tell them I sent you. So here we're going to click empty visual and click create. So this will indeed create our programming area where we're going to create this program. Now, a few other things to notice is for each of these devices, and this goes for any of the IoT devices within Cisco Packet Tracer, we could click on these and it's going to give us some direction on what to do. So for example, we have to use an API of analog write to be able to adjust this color. You have 3 different pinouts. That's why I told you it's important to follow the pinouts. In fact, let me turn those on. Preferences, always show ports. And you can see A0 to D2, which is going to be for red, A1 to D3, which will be green. So just some indications that where you can find some of this information. And you can implementing Blockly programming. To do so, let's go ahead and click our SBC board, and you're going to click the programming tab. Now, you should have already set this up in the last video. Again, if you did not, go back. And we need to start telling our program what we want it to do. So we're going to start here in program, and I'm just going to move this over so we can see it a little better and give us some more screen real estate, okay? So what we want to do is create some functions, variables, because the variables are what we're going to call to action as we build this program. So the first thing we could do is drag over this variable, and it's going to say set item to, it's just blank right now. But what we want to do is create a new variable, and we're just going to name this guy motion. Now, as soon as you do that, if you click variables, you'll notice it does indeed drop that variable into the list of variables that we could work with. Now, we also do need to set some functions, and we're just going to create some to-dos, okay? Now, again, name this something different. I'm just going to name this guy motion sensor. Hit enter. You'll notice it indeed does drop this down here as well. Now, we do need to create a couple more of these. I'm just going to put this one over here, and I could read or name this one read from sensor, whatever you choose. But if you're trying to follow along easily, I recommend you follow along with what I'm actually putting in here. And again, we want to grab another one in here, and this one's going to be motion entry. And you have to excuse my voice today. I kind of lost it after the Super Bowl. Go Birds, all right? I'm a huge Eagles fan, as many of you know. So there we go. We have this motion entry in here. And now we need to start telling what we're reading from. So we have all these different pinouts on our board. We need to let the program recognize those. So to do that, we're just going to click pin access, and we're going to grab in one of these pin mode slots. Now, we could start off with pin slot 0 because we are reading from pin slot 0, which is our motion detector, right? And I could just click duplicate. I'm just going to duplicate this several times here. And in fact, we're going to duplicate this so we have 6 total. So 1, 2, 3, 4, 5, and one more 6. We can just drop him in here. Now, we're going to have slot 0 as an input. We're going to have slot 1 as an input. We're also going to have slot 1 as an output. We're going to have slot 2, 3, and 4 here. And these are all going to be outputs, okay? Meaning we're not putting any information into this pin. So the only 2 that we could essentially use as inputs with this configuration is the door and the motion sensor. Now, bringing this back over, we need to give it a loop, okay? We need to tell it while it recognizes this input, do what with it, okay? So we're going to create a loop here, and we're just going to do a repeat while. So this is creating a while loop. Now we need to grab some of our functions and apply them within this loop. So one thing we also want to do is go to, where is it? Let's go to math, nope, loops, logic. We need to grab true over here. So while the input is true, what's it need to know? Well, it needs to know about these functions. So we're going to use read from sensor, and we're also going to use motion entry. So we could drag him in here as well. Now we need to give it a delay so it knows how many milliseconds to do these for. And with this, we're also going to change the value here to 5,000. And this just helps make it easier when we're trying to set up the SMTP for the email. It'll go through and only send one email, not 100 some emails. Now there's various ways you could program this. I'm doing this as simple as possible for you guys. But again, take this knowledge and leverage it and expand from it. And if you want to learn programming well, again, check out Mr. Fred at getmecoding.com. His YouTube link is in the description below, and I highly, highly recommend you guys go down there, pay him a visit, subscribe, and learn some more programming basics. I mean, it might seem very fundamental. You're learning some Scratch, you're learning some visual programming within the blocky type coding paradigm, but it just sets you up so you have that super foundation that you can take and grow with you. So from there, we need to start setting what we're doing with our variables. Now I do want to go to math. We're going to grab this little 0 here. We could put him here. And we also need to grab our function and our motion sensor function and apply it to that variable. Next thing we need to do is go back to variables. We're going to grab this guy, and we're going to set motion and then digital read. So we could go back to pin access, and we're going to say digital read slot 0, since that's the motion detector. Now, one other thing I want to do here is give it a text command, which is print. So this is going to echo anything out within our output down here. And the reason why we want to do this, and first of all, let's set that to motion. The reason why we want to do this is because we need to know what the value for motion will be. So in fact, if I go over here and I just click run and I just hover over my motion sensor, we should get a value here, 1023. So we need to know about that value as we continue. So now that we know what that value is, we could click stop right there, and let's continue programming this. So within our motion entry, we need to give it some logic, right? If it's going to do something, if something is true, do this, otherwise do that. So we're going to drop him right in there. And for this, we also need to set a variable, and we're going to set, we need to do, where is it? Let's go back to logic. We're going to grab this guy. Whenever you click on any of these devices, you kind of get an idea of what you need to do. So this one here is saying use the custom write API, and then here. So if motion, grab our variable, if our motion variable, he needs to go in that block right there. I keep grabbing the wrong one. Grab that. If our variable motion is equal to, and now we could just right click, duplicate this guy, and this is where we need to enter our value. So this will be 1023. Then it's going to perform the actions that we want it to. So here we could also just go back into our pin access, and we need some analog writes and digital write or custom writes. And this goes back to when I told you guys earlier, when obviously our LGB will use the analog write API for the control of all this. So that's where I'm getting this information from. So we could pull over two analog read and writes, or I'm sorry, two analog writes. So I'll just pull him over, drag and drop him. I could just duplicate him, snap him into place. And he's going to be slot 3 and he's going to be slot 2. And then we could just duplicate these values, drop it in here, drop this guy in here, and he's going to be 1023, not Q, and then this guy is going to be 0. Now we need our custom writes, so let's go to pin access, custom write, okay, and we can duplicate him while we're here, snap him into place. He's going to be pin slot off. When it does not detect motion, it's not going to know what to do. So that's the else part. If this detects motion with this value, do this. Else, meaning if it's not recognizing this motion, just go back to this. So the else will almost act as the default state that our environment's going to be living in while the program is running. So we could actually just copy, we're going to duplicate these guys. We need the analogs again, and then we need our custom rights. We could just drag him down and one more. And basically these values are just 1, and he's going to be pin slot 4. Now, we can just duplicate this guy one more time. He's going to be 1023, and then this guy again will be 0. Or I'm sorry, this needs to be 2, and that's for our light. Now, this will work, but when it goes reversed, so he'll be 0, he'll be 1023, and then he will be 0, and the bottom guy will be 0 as well. Now, I want to take it a step further, because right now, if we run this, we're only going to be able to notice it within our actual topology environment. I want to also be able to dictate and reference this within our little printout here from the visual scripting. So we could add some more print text here. So we could just drop a print in here, and then we could just grab a, where is it? We need the, well, it's red, indicating that there's no motion, the door's not open, and the light is off. So if I right click and drag my mouse over the sensor and give it a couple seconds, you'll notice the door does open, the light comes on, and our LED indicator does turn green. But we want to be able to send an email. So first of all, did we ever set up our SMTP quotations here? So whatever we have in here, this is a string. It'll just print it out. It's not going to perform any function anytime anything is in those quotation marks. So with this, we could just say vault door is open, and I could just fix that. Notice it does not matter what spaces because it's within that string quotations. And then I could just right click this, duplicate this, drag this down, and we could just say closed or whatever else you want to. So right now, as it sits, if we run this program, everything's going to work without email. And I'm going to run this and show you. So if we run this, so you're seeing by default it's closed. Our LED light is now coming on. Emails within here. No, we did not. So let's go to our mail server, and let's go to email, and let's configure this guy. So actually we need to go to services, email, and we're going to set the domain name as learntechtraining.com. We can just click set. We're going to create 2 users, SBC, Cisco will be the password. Click the plus button. Just click stop here. And we need to create another function. So what I'm going to do is create another to do something. I could just put it over here since we have room, right? Let me just move this up. And I'm going to, and then admin. And then Cisco yet again, just for simplicity within the lab. We could close him out. We could go to our laptop, and we need to go down here, and we're going to configure the name as admin. Email address will be admin@learntechtraining.com. Incoming server is 1.1.1.1. Outgoings 1.1.1.1. Username again is admin. Password is Cisco. So we could save that. Now let's go to our SBC board. Now I like to do it both here and in the program, because then we could send and reply back to emails from here. So this is going to be SBC at learntechtraining.com. Again, mail servers 1.1.1.1, 1.1.1.1, and then username will be SBC, password is Cisco. Save him, and all is good for our email server. However, we need to add some more programming code in here to make that work, to where it automatically sends out the email. So we could name this email, right? Now, what we need to do is another if statement. So we're going to just say if do, all right? So we're going to go to logic, if do, all right? You can see everything's default to pull over our variable, and we're just going to pull in motion. And then what we need to do is create our email. So if we go down here to email, we need to set up our client, and then we could also click send email. So this is very simple. but I'm also going to create another text with a printout stating in the actual program here that an email is being sent. Email is sent.